Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad and now we want to present to you about relationship between student study hours and their scores. Now this is our group members. The first group member is myself, Muhammad Ali Bayana. Second group member is Nur ALYA AFRINA binti ZAINUDDin, and the last group member is one BATRISYIA ADRIANA binti MOHAMAD FARAOK. Now, for the introduction part, in the context of modern education, the relationship between a student's study hours and academic success is an important aspect of their learning process. Students require different amounts of commitment based on the difficulty of their understanding, information that they get, and learning capacity and their goals in life. Understanding the complex relationship between the number of study hours and the resulting academic outcome has far-reaching implications for the success of educational system and the overall growth of students. The data below is the relationship between number of students who study and the marks they got that had been obtained from the website kaggle.com. So this is our data. We have 25 data in total. So for our x variable is number of students studied in hours, and the y variable is the scores that they get in their exam.
As we know, the standard linear equation for each coordinate is y equal to a plus bx. Therefore, the 25 data that we get can be substitute the value of x and y into the linear equation, and the data will show like this. So now, let us take a look how Mapper can help us with linear modeling. We need to be able to enter the data into the Mapper. We need to define the data vector for each value, which the 25 data that we get. So we need to transfer in terms of x and y into the m and y. We set up the matrix for m, which the dimension 25 by 2, and the matrix of y with the dimension of 25 by 1 using the data that we obtain. After that, we find the M transpose using the functions transpose. We define M transpose as my. The dimension of the transpose of matrix M is 2 by 25. Next, we need to multiply the M transpose with M. The dimensions of M transpose M is 2 by 2. After that, we need to check whether the condition is satisfied. Since the value is not equal to 0, so both conditions are satisfied. The least solution is unique. Next, we need to find the M transpose multiplied with Y. The dimension of M transpose multiplied with Y is 2 by 1. Finally, after all of the calculation, we can obtain least square solution by multiplying the inverse of M transpose with M and the matrix of M transpose with Y. Then, the answer will be the value of A and B. The best fit linear curve is C equal to 9.7758x plus 2.4837. Lastly is the magnitude of error vector. However, we need to find the error vector value first. The formula for error vector is y minus nv. For the matrix of MV, we need to multiply the matrix of M with the matrix of V that we had been calculated in the previous working. After the calculation, we can get the value of the error vector, and the matrix error vector is 26.8713. Now, let us take a look at the graph. The graph is shown is x against y, which is the x is the number of students study in hours and y is the score. Based on the linear curve C, we conclude that when the number of students study in hours increase, the score will increase by 9.7758. For the graph of residual, based on the graph, we can see the relationship between error vector and the x value. The data in graph seems randomly scattered and no pattern. So it indicates that there is a linear relationship between x, which is the number of students studied in hours, and the variable y score.
So first of all, we need to put our data in a system. So this is our data in a quadratic system. So next we want to find the quadratic function using least square solution formula. So the formula is M transpose M V times V equal to M transpose Y. So what we want to do is we want to find the value of V. Okay, so the second, as we can see on the second photo, is the matrix M value. So for the first column is the list of one value. The second column is the value of our x, and the third column is the value of x squared. And the V matrix is just the value that we need to find, which is the value of A, B, and C. And next is we want to find the value of y, which is our variable y in our data. Next, we can find the m transpose m value. So this is the m transpose m value. So after we find the m transpose m value, we need to find the determinant of m transpose m. And the value of the determinant is not equal to 0. Since both of the matrix is linearly independent and the m transpose m is invertible, thus the least square solution is unique. So we need to find the value of m transpose y, m transpose m inverse, and we can insert the value in the equation, so we can get the quadratic equation, which is y equal to 0.0287 x squared plus 9.4759x and plus 3.0915. So next part is we want to find the error vector for the quadratic model. So the formula for error vector is E equal to y minus mp. So we already have the m matrix value and p value, so we just matrix multiply it. So we got the answer over here on the second photo. And next we just insert the value in the formula. So we got this list of error vector, and the magnitude of error vector is 26.86. So after we already done the error vector, we want to see the regression plot. So we do the scatter plot for our variable x, which is student study in hour, and our variable in y, which is our scores. So as we can see on the scatter plot, we can conclude that if number of students study in hours is increases, the scores, which is our y variable, will also increase. Next is the residual plot. So based on the residual plot, we can see that the points are randomly scattered throughout the plot. So it indicates that there are linear relationship between variable x and variable y, which is our variable x is number of students studied in hours, and our variable y is the student score. So we can say the quadratic model is a good model.
Cubic model. We know that equation for cubic is y equal to a plus bx plus cx squared plus dx cubed. So we substitute x and y into the cubic equation, and the data will show like this. We use cubic model data, which is y equal to a plus bx plus cx squared plus dx cubed. By keying the data into the mapper software, the data generates cubic equation as shown. We can see the dimension for m is 25 by 4, while dimension for y is 25 by 1. Least square solution. We multiply m transpose with m. The dimension for m transpose m is 4 by 4. And then we check whether the condition is satisfied or not. Since the value is not equal to 0, so both conditions are satisfied. The least square solution is unique. Next, we need to find m transpose y. The dimension for m transpose y is 4 by 1. From the previous calculation, we can get the least square solution by using v equal to m transpose m inverse multiplied with m transpose y. So the answer will be the value of a, b, c, and d. The best fit cubic curve is v equal to negative 0.1926x cubed plus 2.9987 x squared minus 3.7971x plus 19.3177. Last, we need to find magnitude of error vector. Before we find magnitude of error vector, we need to find the value for error vector. The formula for error vector is y minus mv. After the calculation, we can get the value of magnitude of error vector. The magnitude of error vector is 24.6. Scatter plot. Based on the graph, we can conclude that the graph indicates a positive relationship between students studied in hour and score because the data show an increased pattern from the left to the right.
Residual plot. Based on the residual plot, we can see that the points are randomly scattered, so it indicates a relationship between the number of students studied in our X and score Y. Conclusion. We can conclude that the best fit curve obtained in this study with the least minimum error is cubic model, with the magnitude of error is 24.6. This is the best approximation because it has the minimum error in the term of its magnitude, compared to linear model with the magnitude of error is 26.87 and quadratic model with the magnitude of error is 26.86. I think that's all from our group. Thank you.